Hey folks, this addition to the first video is an introduction to your first lab of the unit. We are going to spend a ton of time in this unit on the lab because the people who are fully remote can do it too. So your first lab assignment of this unit is this one. Determine the force constant of a spring using graphical analysis. What I mean is you are forced to produce a graph and analyze only the graph to determine the force constant. So this is that's your basically your constraint. And so you will take data that will end up being put into a graph. Maybe you calculate something with it, maybe you don't beforehand, but whatever you do, you have to find something to put into a graph that you can then analyze only the graph to figure out the force constant. And to give you like the biggest hint of them all, you need to analyze the line of best fit for your data. Okay, so you're going to produce the following sections. This is a very brief lab when you do this. So you don't, nothing fancy here. Okay, so purpose, materials, procedure. The procedure you'll have to write your own. Okay, the purpose is there. The materials I'm going to tell you about. The procedure you write on your own. Make it very short and very general. Don't say like 50 grams or 100 grams, just say various masses, that sort of thing. Data should go in a table. Your analysis should be any calculations you need to do before you graph, and then it should include your graph. You can draw by hand if you really want to. You should use Excel, or if you want, Google Sheets or some other spreadsheet program to graph it, because then you can do a line of best fit and analyze that. And in your conclusion, you're just going to explain the physics. I don't want you to describe what you did. I want you to describe why you are able to do what you did. So, what was the significance of the graph? Why does this concept lead itself to a graph that's easy to analyze? And what is the concept? So definitely kind of, play teacher a little bit and do a very, maybe one or two sentences about the concept that goes into this, and then focus on how you were able to, or what is the reason you are able to apply the physics to make a graph. Okay, so the materials that you're going to use are obviously a spring. So people at home are going to get this type of spring specifically, just because that's the one that fit in little boxes that you took home. People in the room are going to get as large a variety as possible of springs that I can give. You will get at the very least two masses. Now people at home, if you like own a scale for food or postage, you're welcome to find other objects. But these two masses are actually enough to get 3 data points out of. And so 3 is enough. And then if you really think there's a use for it, in your boxes at home, there's 1 meter of physics string. Yes, this red and white braided string is called physics string. It's very strong. And then the thing that you have to provide is a ruler or tape measure or something. You definitely want to convert everything to meters. So whatever units are available on the ruler you have, convert them as necessary. And then you'll need something to hold the spring. And so that's kind of where the people at home are going to need to be the most creative, because we'll have like ring stands in the room to hold springs like this, but you want to just find something. So you might need to like play around a little bit. These rings are like, my pinky fits through it, but not much bigger than that. So, find somewhere to hang the spring before you start collecting data. And that's it. So we will spend like majority of class days on labs in this unit, I think. So we're going to do a lot of just like thinking and processing in the lab. Now, definitely work in groups, and that includes people who are at home. So people who are fully remote, if you want to zoom in or otherwise collaborate with anyone who's actually in the building, heck, you can collaborate with people in other physics classes if you want to coordinate that. So all of my AP students are doing these labs. Collaborate with whoever you want, and then make sure that you produce your own lab once you've done it. So really for this one, I want you to stick to collaboration only kind of talking about what you're going to do and not what actually goes into the lab. Thanks.